Hello once again. Welcome to the continuation on the vectors that I started with you in the previous videos. In the previous videos, we started learning about vectors and we started with introduction to vectors and we moved on to addition and subtraction of vectors, and also we looked at multiplication of a vector by a scalar, and the last thing that we handled on the vectors is position vectors. And all of this, we've done a detailed explanation on it, and also we've solved some examples on it as well. And I hope you understood it and you enjoyed the lesson as well. So in this video, I want us to continue and handle another aspect of the vectors, okay, and that is triangle law of vector addition. As you can see from the board, I've written triangle law of vector addition, which is the same as resultant of vectors. Okay, so anytime you hear of triangle law of vector addition, it's just the same as resultant of vectors. Okay, and I will encourage you to do well to watch the previous videos, because the previous videos lays the foundation. Okay, we are going to apply all the knowledge that we've gotten from the previous videos here. When we started the vectors, I explained to you that vectors is one of the topics in mathematics which is very broad because it has many subtopics, okay, and students struggle a lot with it because they don't get a good foundation to it. So I explained to you that don't skip any of the videos, because any of the knowledge that we are going to acquire, okay, from the basis, we are going to apply it whilst moving forward. Okay, so we started with the introduction to vectors, we move on to addition and subtraction, then we looked at multiplication of a vector by a scalar, and the last thing that we looked at is the position vectors, which when I was teaching you the position vectors also, I taught you inverse of a vector, and we are going to apply all those things that we've learned here, okay, under the resultant of vectors. Okay, so it's very important that you watch the previous videos to get the basic knowledge and foundation that you need to be able to handle this aspect as well. And please don't forget to like the videos and also share them after watching. And if you're watching for the first time, please do also follow the page and also subscribe to my YouTube channel as well. Okay, you can see that I have an example on the board that I want to solve with you, but before we tackle the example that I have on the board, as usual, I'm going to do a brief explanation on the resultant of vectors. Then when you gain the understanding, then we can proceed and solve the example that I have on the board. Okay, so now, having any three given vectors, and that three given vectors is represented by three sides of a triangle, that representation, there is an addition law that governs that representation, and that law is what we refer to as the triangle law of vector addition, which is the same as resultant of vectors. I hope the explanation is clear enough up to this point. I don't want to bore you with a lot of theories and so much talk, so I will just go ahead and do an illustration on the board, and it will help you understand it perfectly. Okay, so just follow the illustration that I'm going to do on the board and you are definitely going to understand. Okay, so now when I have any three given vectors, and that three given vectors is being represented by three sides of a triangle, there is an addition law that governs that representation, and that is what we refer to as resultant of vectors. Okay, and I'm going to do an illustration of that. Okay, so let me draw a triangle first. I'm going to draw a triangle. So this is my triangle, and I'm going to label the size of the triangle. Okay, so let me label here A, here B, and here C. Okay, so now if you are labeling a triangle, it's important that you stick to a particular pattern. Okay, either you move clockwise or you move anti-clockwise. Okay, don't mix the letters together. Okay, that's very important. So you can see that I started here A, and I moved here B, and I also moved here C. Okay, that's how you label a triangle or any given plane figure. Okay, either you move clockwise or anti-clockwise. So if I started here and I make here A, it means I'll come here, make here B, and here will be C. Either you move clockwise or anti-clockwise. That's the proper way to label a triangle. Okay, so now let me say that I have AB as a vector. Okay, so AB as a vector, meaning that I'm moving from A to B. So the arrow will go in this direction because I'm moving from A to B. Okay, and also let me say I have BC as a vector. So my arrow will move in this direction. So it's very important. So meaning that I'm moving from B to C. So I have the vector BC. And also let me say I have AC as a vector, meaning that I'm moving from A to C. The arrow will go in this direction. Okay, now the arrows are very, very important. You can't ignore them. Okay, but because it plays a role in the solution. Okay, so the arrows are important. And in the introduction to vectors, I explained to you that a vector is any quantity which has both magnitude and direction. So it means without the direction, it means the thing is not a vector. Okay, so the arrows shows the direction and it's very important. Okay, so don't ignore the arrows, pay attention to it. Okay, so I'm saying that let's say I have vector AB, so moving from A to B, that's why the arrow is pointing to this direction. And let's say I have vector BC, I'm moving from B to C, that's why the arrow is pointing to this direction. And also let's say I have vector AC, okay, the arrow is pointing to this direction. Okay, so AC. Now there is an addition law that governs this representation, and that law is sort of referred to as the triangle law of vector addition or resultant of a vector. And the law says that always, that's what the law says. It says that when I pick the vector AB, okay, so when I have the vector AB, when I add it to the vector BC plus the vector BC, it's supposed to give me the vector AC. Okay, that is the law. Okay, don't get worried, it's very simple. I will explain again. Okay, so I hope you understand the representation. So having this representation, the law says that if I pick the vector AB and I add it to the vector BC, it should give me the vector AC. Now take note of the movement of the arrows. So now from A to B, from B to C, it should give me AC. Okay, so AB plus BC should give me AC. You can see that it is moving in the clockwise that like this from and also to here. Then we have the AC. Now, maybe someone is thinking, why not AB plus BC to give me CA? Take note that I say that the arrows are important. The direction of the arrows is very important. Okay, you cannot say that AB plus BC should give you CA. Why? Because you are moving from A to C, not from C to A. I hope you understand. And so that's why it's supposed to be, to get my AC, which is the base of the triangle, is supposed to be AB plus BC. That should give me the AC. I hope the explanation is clear enough up to this point. I'm going to use another illustration. Okay, so just follow. Let me clean this one and do another illustration. Let's say I have another triangle. So this is my triangle. Let me label the size of it. Okay, so let's say I have P, Q, and R. let's say I have vector PQ, meaning that I'll move from P to Q. And also let's say I have vector QR, meaning that I'll move from Q to R. Now, the triangle law of vector addition, it says that when I add the PQ to the QR, it should give me PR. That's the law. Okay, so for me to get my vector PR, which is the base of the triangle, the base side of the triangle, it should be the addition of the vector PQ plus QR, and that will give me the PR. Okay, and that is the triangle law of vector addition. And I'm emphasizing that you cannot say that PQ plus QR should give you RQ. No. Why? Because the arrow is moving from P to R, not from R to P. Okay, so you cannot say that PQ plus QR should be equal to RP. No, we have PR, not RP. I hope the explanation is clear enough. Okay, so that's the triangle law of vector addition. Now, the trick is that when we start solving the questions, you know, I'll show you the trick. The trick is that any one that they are asking you, any side of the triangle that they are asking you to find, just put that side at the base. Okay, that's it. So, for example, this one we are being asked to find PR. So I will draw the triangle in such a way that the PR will come at the base of the triangle. That is what you need to do. That will make it very simple. So that's the trick about it. So with this question, we need to draw the triangle. That will guide us to know what to do. So whilst you are drawing the triangle, we should take note of what the question is asking us to find. What the question is asking us to find is PR. So I'll make sure that the PR comes at the base of the triangle. Okay, that's what we will do. Okay, so I hope the explanation is clear enough up to this point. Let me do one more illustration before we come to the question. Okay, so let me clean this from here and do one more illustration. Okay, so now let's say I have a triangle again. This is a triangle. Let's say I have a S, T, and U. Okay, so I've labeled the size of the triangle. So let's say I have vector ST moving from S to T, and let's say I have vector TU moving from T to U. Now the addition law, the triangle law of vector addition, it says that when I add ST to TU, it should give me SU. I get me? It should give you SU. So SU equals to ST plus TU. You should keep it in mind. That is how it always goes. Okay, so to get my SU, it's going to be my SU is going to be ST plus TU. Okay, you bring the arrows, which are very important. Okay, the arrows are important, so don't ignore the arrows. I hope you understand. Or you can equally write it like this, that your ST, okay, moving from S to T, your vector ST plus the vector TU, so plus the vector TU should give me the SU, the vector SU. Okay, that is the triangular law of vector addition. I hope the explanation is clear enough up to this point. Okay, so we are going to use this knowledge to solve the question. We are going to draw a triangle for the question. And don't forget, I've explained to you that always, whatever that they are asking you to find, let it come at the base of the triangle. So for this question, we have to find PR. So I'll draw the triangle in such a way that the PR will come at the base of the triangle. Okay, I hope you understand. So let me clean this and let's start solving the question. Okay, so let me write down my solution. Now let's read the question again. It says that if PQ is equal to negative 1, 3, and RQ equals to negative 5, negative 8, we should find PR. Okay, now let me bring the arrows here, which are very important. I forgot to bring the arrows, so let me bring the arrows and let's continue. Okay, so I forgot the arrows, so I brought the arrows. Okay, so let's continue. So it says that if the vector PQ equals to negative 1, 3, and the vector RQ equals to negative 5, negative 8, we should find the vector PR. Okay, and this we need to apply the knowledge on resultant of vectors, which is the same as the triangle law of vector addition. Okay, so I'm going to draw my triangle first. So let me draw my triangle. So you first need to draw your triangle, and I hope you are following. So this is my triangle, and I've explained to you that always whatever that you are being asked to find, that is what is supposed to come at the base of the triangle, which is very important. You are being asked to find the vector PR. So I will draw the triangle in a way that the PR will come at the base of the triangle. Okay, so I'll first put my P here and I'll put my R here. I hope you understand up to this point. Then of course it means that one variable is left, which is going to be the Q. So it means the Q will come up here. Okay, you can see that we have three variables. We have P, Q, and R. Okay, now I told you that always whatever that they are asking you to find, it should come at the base of the triangle. So in this question, we have to find PR, and I brought PR at the base of the triangle. So it means that it's left with the letter Q. So the Q will come up here, obviously. Okay, I hope the explanation is clear enough up to this point. So now that we've labeled the size of the triangle, now let's check the question and bring the arrows. I explained to you that the arrows are very important. So now we are going to go through the question again, and we are going to indicate the arrows on the triangle based on how we see it. Okay, so let's start with the PR. You can see that you are moving from P to R. The arrow is moving from P to R. So you bring your arrow like this, P to R. I hope you understand and you agree with me. And also, let's come to the PQ. The arrow is moving from P to Q. Okay, so P to Q. So the arrow comes this way. So P to Q. And we have RQ. Please take note, it's RQ, not QR. The arrow is moving from R to Q. Okay, so I'll do my arrow this way, R to Q. I hope you understand up to this point. So look at it, RQ from R to Q. So this is how the triangle is supposed to look like. Okay, and I hope you understand up to this point. So now, all that you need to do is that you put the formula down. Okay, irrespective of how your triangle is looking like, you just follow the general form of the triangle law of vector addition that I showed you. Okay, and that is, let me write it down. I explained to you that to get my PR, so I write it down. So to get my PR, it should be equal to my PQ plus QR plus QR. I hope you understand. Now maybe someone is asking, why not RQ? Because the arrow is moving from R to Q. I've explained that the law is constant, that it always has to be in this direction. Okay, so to get your PR, it's supposed to be PQ plus QR, not RQ. But in the question, we're given RQ, so it means that we have to do something to this side of the triangle so that we can get the QR that we need. That is when the inverse of a vector that I taught you, it comes here. Okay, because I've been explaining to you that you are going to apply everything that we've learned on the vectors. Okay, so the inverse of a vector that I taught you, it comes here. Again, the law says that when we have P, when we want to find PR, okay, whatever we want to find, we put it at the base of the triangle. That's why I put the PR at the base of the triangle. So to get the PR, it should be PQ plus QR. Okay, though the question gave us RQ, you are not supposed to say that PR is equal to PQ plus RQ. No, because the law says that you move in this direction. Okay, to get your PR is supposed to be PQ plus QR and not RQ. So having that here is given to be RQ, we need to do something to that part so that we can get it to be QR. So the inverse of a vector that I taught you, it comes here. Okay, so now let's continue. So you put your formula down that my PR should be equal to PQ plus QR. Okay, now let's come to the question and just input the values that we have. Okay, I don't want you to get confused, so we are going to just input the values that we have. Okay, do we know PR? We don't know. That's what we are finding. Okay, so we don't know PR, so I'll just repeat my PR there. Bring my equal sign. Do we know PQ? Yes, PQ has been given. We know PQ to be -1, 3. So I'll put my value of PQ there. I hope you understand. So my PQ is given to be -1, 3. Then plus, do we know QR? No, we don't know QR. We were not given QR. We were given RQ. So you cannot assume that it's the same as the QR and you go and put it there. No, it is wrong. We're not giving QR, we're giving RQ. Okay, so just repeat your QR, which you were given here. I hope the explanation is clear enough up to this point. Okay, all that we did is that after we stated the triangle law of vector addition down, we input the values. Okay, we don't know PR, repeat it, equal sign. PQ was given, so we put our PQ there, plus QR, we don't know, we're not giving QR. So we need to find that QR. How do you find that QR? I taught you the inverse of a vector and we are going to apply it here. So you can see that the QR that we have here, to get the QR, we just need to negate the RQ and that will give us the QR. This I've explained a lot in the previous videos when we're teaching on the position vectors. I taught you inverse of a vector. Okay, so I will say that, but okay, I think it's not clear from here, so let me continue from this side. So I write that, but my QR will be equal to, we were given RQ. Again, we're given RQ, not QR. So we need to look for QR. How do we get QR? When we negate RQ, it will give us the QR. Okay, that's the inverse of a vector. So my QR will be equal to the negation of the RQ. Okay, like this. So now let me input my values. So my QR, vector QR will be equal to, bring your negative. What is the value of RQ? RQ is given to be -5, -8. Okay, let's simplify further. So my Q vector QR will be equal to, the negative will affect the value at the top here and also the value at the down here. So we are going to get 5, 8, and I hope you agree with me. Negative times -5 gives me +5. Negative times -8, it gives me +8. So I have my vector QR equals to 5, 8. So now that I've gotten the QR, I'm going to substitute it into this so that we can find the PR. Okay, so therefore my PR, okay, from here we have that my PR will be equal to my -1, 3 plus the QR. Now we know the value of QR. What's the value of QR? It's 5, 8 now. So you put your 5, 8 there. So 5, 8. Okay, then now we simplify. So my PR, my vector PR will be equal to Minus 1 plus 5, it gives positive 4, okay, and 3 plus 8, it gives 11, okay. So I have my vector PR to be 4, 11, and that is the final answer. I hope the explanation is clear enough up to this point. Okay, now let me just do a little explanation before I end the video. Okay, look at something. So you know that to get the PR is supposed to be PQ plus QR. But here is the case from the question. We're giving RQ, meaning that we are moving from R to Q. So meaning that we need to do something to this side of the triangle so that we can change the direction, okay, of this side of the triangle. So it's supposed to be QR. Okay, but from the question we had RQ. How do we change the RQ to be QR? All that we need to do is to negate the RQ. When we negate the RQ, we are going to get the QR. So we negated the RQ that we're given. We're given RQ to be this. When we negate it to give us QR, then we use it to solve the question. That's exactly what we did. Okay, so I hope the explanation was clear enough and you understood it as well. Please don't forget, like the video for me and also share it as well. And if you are watching for the first time, please follow the page and also subscribe to my YouTube channel as well. I'll see you again in another video whilst we solve more questions on this. Bye bye.